There you go. So this is our old friend, Revit, with a blank screen. And this, okay, even we have selected the structural template, but the discipline here is architectural. So select structural. Okay, so make
I
sure.
have a question.
Sorry?
I have a question.
Yep.
So I don't have the option to do structural template. It just says none.
But if you open this, you can change the discipline.
Okay.
Okay, so changing the discipline, it's fine. Okay, so if it's structural, the problem there are most of features work with the architectural template, but structural is good because especially connections between beams and columns, they are more accurate. And if we want to calculate structures, because with Revit, we can calculate the structure, we can dimension the beams and the columns, we can do that. If you are not in the structural discipline, you can't do it. We are not going to calculate anything, but just for being more accurate, it's good using the structural template. Anyway, Revit, structural. First, I always check the project units because, okay, so if you click on manage project units, why? Well, because in my professional life, I'm working with the metric system and I always forget to change this. So let's use feet and fractional inches, square feet, square cubic feet, angles, currency. We don't need money yet. Mass density, we can use pounds per cubic foot, and time is in seconds, and speed, let's say feet per minute. Okay. Probably if you open the US version, all these units would be that way. But in my version, every time I use Revit, I have to select these units again. Okay, so then we can change location. We are not going to use this, but you know that get used to doing this beforehand with a blank screen. Get used to working with a location because it will be easier. If you change location afterwards, you might have some troubles. But if you do this beforehand, that's better. Okay, so here you have architecture, the architecture objects, walls, windows, doors. You can use them even if you are working with the structural discipline. So you can draw a wall, but sometimes you won't find the wall in this level 1 because you are working with structural disciplines, but it's there. So if we select the 3D view, our wall is there. Okay. Well, we have to change the levels. Well, we are changing the levels because I know what we're going to do. And well, let's change it. So we have level 1. Well, this is how I start working. So I name the levels with the same name as the elevation. Okay, so for me, level 0, it's 0. Let's work with level 12 to make it easier. So that would be level 12. And now we can copy this. That would be level 24. And level 36. Okay, so there will be 4 levels because there will be 4 floors in our, well, 3 floors and finally the roof in our building. Okay, and each level is 12 feet. So let's work with level 0. And now, if we are going to work with structures, we need to work with a grid. Okay, so again, this is something that we, I think Revit is not a tool to create the first sketch of a drawing. Hand drawing, it's much better for that. Even SketchUp, it's better if you want to create mass modelings and have different options. When you are working with Revit, you have to, yeah, you have made some decisions. And one of the first decision or the second decision that you have to make when you are designing something is about the structure. In the structure, the first decision is, okay, are we using bearing walls or are we using columns and beams? Nowadays, 90% of buildings use columns and beams. In Roman times, we had bearing walls and vaults and domes and all that stuff. Nowadays, we don't have this, unfortunately. So one of the first decisions is the size of the grid. And well, that knowledge comes with experience. What the size of grid should be. And it depends on the material we are using. If we are using steel, the grid span can be different. If we are using wood or if we are using concrete, okay? We are using steel now. So we are going to work with a grid. So this is number 1. And we're going to use a module, and it's going to be 12. So everything is about 12, so it's easy to remember. So now we can copy this 12. Okay, so between 2 grid lines, there will be always 12 feet.
Fernando, real quick, not sorry to interrupt. Where did you get the grid from? Real quick.
Okay, no problem. We are in File, Architecture, and here we have this tiny icon,
Okay.
grid. Okay.
All right, I got you. Thank you.
Don't worry, you can interrupt me anytime. So that's what I'm here for. If you don't interrupt me, that means that either you are sleeping or you understand everything. So if you interrupt me, at least I know that you are there.
Thank you.
Okay, so we have the grid, 1, 2, and now we have to copy. If you select copy multiple, we can copy 1, 2, 3, 4, and 5. There are different ways to do this. Okay, so I'm giving you time to create the grid lines. But for example, if you create grids like this, and if you randomly copy, okay, imagine that we don't have the same distance. There is something very useful in Revit. If you use annotate, and if you use align dimension, okay, we can take measurements from these grids. So you see that each grid, it's 16, 16, 12, 8, 16, whatever. If we want to make all these measurements the same, we have to click here. You see that here we have EQ. So we do this, and we have the same distance between all the grids. Amazing. Okay, so you can do this, or if you know the distance between grids, you can just copy multiple times, or you can copy randomly, and then you can make them the same distance. Okay. So if you are moving this, you know that you are keeping always the same distance. Okay, so this is useful. If you move the last one, you know that all the rest of the, if you have this EQ selected, if you don't have it, I mean, if you don't have this, then you will move that and it will be different. Okay, so it depends on what you want. Anyway, we have 5 vertical grid lines, and now we are going to work with horizontal grid lines. So we go to architecture, grid, and this is the first one. Usually we have different names. We have numbers in this direction, and we have letters in that direction. So that would be A. Okay. So we are going to do the same now. Well, this is something I'm going to do this because I know what I want. I told you before that I have already done this, so I know what I want. And we are going to work with a module. This is 12 by 12. And then we are going to work with double, 24. And then we're going to work with 4 times 12, which is 48. Why are we doing this? Because this is what great architects do. So if they do it, who are we to do something different? What are great architects, or who are the great architects? I don't know. These guys, I told you, Herzog and de Meuron. I showed you this. Okay, so they have a module. If you see, they have a structure, and we have columns here, 1, 2, 3, 4. So this is a module. Okay, this element here is a module, and we have columns here on each corner of this. Is it a square? Is it a rectangle? I don't know. I don't mind. But what are they doing? Well, okay, so if they want if they want an auditorium here, so they have a double module. So they have 2 modules. If they are going to work with restrooms or whatever, we have half the module. If they are working with a staircase and elevators, they are using half the module. And if they are working with a bigger office or room or whatever, they have a double volume. And for this classroom or whatever, what is this? This is 1.5. Okay, so if you decide a good module and you have a grid, then you can play with these distances, but you can play, okay, this is 1 module, 2 modules, 1.5, half, 2.5, whatever, but you have decided the module. And here, yeah, you see that we have all the spaces here, the restrooms, the cabins for projection, something in the auditorium, and they are all related. All these elements are related to the first module that they have decided. So this is a very important decision. Well, I decided that we are going to work with this 12 by 12. So I'm going to copy this 12, and the next one would be 24. Okay, and the next one would be 24 and 24. Okay, so this is our yeah, this is where our building is going to be. Okay, so we have these grid lines, and our building is going to be within those grid lines. And when we need a bigger space, we can use 2 modules. If we want a small space, we can use only 1 or half. But get used to doing this when you are designing. At the beginning of the design process, you can use freehand sketching, whatever, blah, blah, blah. That when you're happy with your design, try to put all these lines that you have done into modules, and then try to think of the structure of that building. First, you have to think about the material, and then if you know the material, you know what the distance should be. I know that this is steel, and 12 goes well. Okay, because why do I know that? I don't know, because maybe because I have designed thousands, but not thousands, but a lot of steel structures, and I know that a square 12 by 12 is good, and a rectangle 12 by 24, it's good as well. Okay, now we have to start designing things, structural elements. So what do we have at the beginning of the structure? We have foundations. Okay, so we can go to structure here. And here you see we have foundations, we have slabs, we have foundations for walls, and we have isolated footings. Okay, this is what we're going to do. We're going to have isolated footings with a steel column on it. And where are these footings? They are here in intersections between vertical and horizontal grids. So that's why having the grids, it's very useful. Why? Okay, so let's select isolated footings. Well, in my computer, no structural foundations family is loaded. I don't know, maybe in your computer it is. Someone has footings loaded on the project.
Yeah, mine went through, I think.
Okay,
Yeah, I have some too.
anyway, if you don't have it, I'll show you how to, you have to load or you can go to insert here, and then you have to go to the US Imperial. And we have a lot of things here. At the end, we have structural things. Okay, so we have structural columns, connections, structural foundations. We are going to insert a lot of things, but we will start with structural foundations. And here we have a footing, rectangular, and we have piles or boreholes. These are deep footings when the soil, the rock is it's underneath, it's very deep, it's not shallow. Then we have to use these piles. If we are founding our building on rock, most likely New Hampshire is the granite state, so we have rock everywhere. Okay, so most likely we can have these shallow footings or rectangular footings, and we don't need piles. Okay, but if we're, especially we're working in close to rivers or lakes, well, there are a lot of rivers and lakes in New Hampshire as well, but this is a huge decision that we have to make, and we have to rely on, not on architects, but we need to test the soil to see where the solid rock is, and then we have to make a decision about the foundations. Okay, so let's imagine that the rock is not very deep, so we will use rectangular footings. So I'm going to insert rectangular footings here, and here it is. What is the dimension? Well, I don't know. Let's say that this dimension is okay. So we have isolated footings, and now we can use this command, add grids. Okay, so but if you have, we have already selected footing, so we can place footings one by one. That's why we have this element, and we don't see this. The footing is here. See? But on level 1, we don't see the footing. This is because of the view range. So if we make this unlimited, okay, the footing is here. Okay.
What level did you want the footings at?
The footings, oh, for sure, they have to be on the lowest level. Yeah, this is the footing.
Okay.
But the footing has to be on the lowest level, level 0. Okay. So this is a footing, and then you can select this and you can copy the footings. We will do this in different ways. Okay, so first you select this, copy, and then you copy multiple, and you have 1, 2, 3, 4, 5. Then you can select well, you can select the footings, and then you can copy multiple again. That's why having access is quite useful. Okay, because without access, we don't know what we are copying. Okay, so that's the traditional way to do this. There are other ways to make it faster. So once I have inserted the first footing, I can select and I can use array. Okay. So I can use array, will be detached from grid due to inconsistency. Okay. And you see that we have number and move to second or move to last. If we move to last, and how many footings do we have? 1, 2, 3, 4, 5. And we select here 5 footings. Then we only have to select here the midpoint, the last point, then whoop, we have 5 footings here. Okay, so this is faster, but it's the same outcome. But there's something even faster here. So I'm going to delete this one. And if I select isolated footings, I can select add grids. And if I select all the grids, I have all the footings in just 1 second. Finish. That's it. Isn't it wonderful? Okay, so we can do this because we are working with the structural template. I don't think this works with the architectural template, or maybe in Revit 2021 it works, I don't know. But if you are using structural templates, that works for sure. Okay. So on the east elevation, make sure that all footings are here underneath the lowest level, level 0. You can check the 3D. We have footings here. I'm going to move this. Look. Yeah. Well, so first, we have to start buildings by the foundations. Is that footing enough? Well, usually footings work better if they are connected to each other. So we need beams. We're going to need beams connecting footings. Okay. So we're in the structural template. So let's select beams. And what kind of beam do I have here? I only have this MW shape. Someone has concrete structural beams? If you click here in beams, do you have more families? Because I only have one.
Yeah, I have the concrete ones.
Okay. So if you have the concrete ones, you can use that one. Or if you don't, you can insert load family. And then where is this? I think this is in structural framing. In structural framing, you have concrete, steel, wood. Today, we're going to use steel as well, but let's work with concrete so far. And here we have a rectangular beam, we have joists, and we have other kind of joists. Well, that's interesting. We will use them, but not today. So today we're going to use the concrete rectangular beam. Open. And now, structure, beam.
I can't find that one in my library right now.
So you can't what? You don't have structural concrete?
I can't find it in the library.
Well, that might happen. Are you working with your computer, or are you working in the CAD lab, or where are you?
I'm on my computer.
Okay, so that might happen. You have footings, by the way.
Yeah, I do.
Okay, you don't have concrete beams.
I don't know if I just missed a step when you were loading it in, but I couldn't get to it where I was at because it brought me straight to structural precast.
No, it's not structural precast. It's structural framing.
So I'm in English Imperial, right?
Yes, in US. Well, I have US Imperial, but it should be the same. English people.
Yeah, it's just. Yeah, it brings me, the only folder I have is structural precast.
Structural precast. I'm going to, can you share your screen?
Yeah, I think I'm just missing a step, but I'll share it.
Now you can share it.
You gotta enable the screen sharing, I guess.
I have Corey. Yes, now you can do it.
So that's on the Reddit one, right? Or Revit.
Yeah.
Can you see
English-
the
Yeah.
tab I have open?
I can see insert. Yes, sure. English
Oh.
Imperial.
So English Imperial, this is the only one I
Structural.
had.
Ah, you only have this. Can you open someone else or some yeah other country to see?
I think it's all the
Prefabbricati
same.
strutturali. Ah, muy bien. With a wonderful Italian. Uh,
Did I do, am I in the wrong beams or something? Because you go to structure. One sec.
Structure. No, this is a beam system. It doesn't work. Open that beam. Let me see what you
Okay.
have and open different types. You only have that type. Oh,
Yeah,
here. You complete
that's what I did wrong. Thank you.
Okay, no problem. So stop sharing your screen if you don't mind.
Thank you.
Okay. Here we are again. Anyway, US Imperial, if you don't have families, it might happen. Let me know and I can send you a link to Revit families, or at least I can send you the families that we are using. Okay, or I can post the families we are using on Canvas. So if you are shy and you don't want to interrupt me, you can use the chat or you can email me. I'm sorry, but I don't have families, and I will email you with families, or I will post families on Canvas. Anyway, we have the structural whatever framing. Yep, a concrete rectangular. I think I loaded it. Yeah. And now it's quite easy because we only have to connect all these beams together. By the way, we're not using, well, we can use this one as well. Okay, we can do this and then we can copy. If we select copy, we can copy multiple, we can use arrays, whatever. But this is important because at the end we have like a grid and everything will work together. If we connect this footing to this footing with this beam, if there's something, because soil, we don't know anything about the soil. We can have some testing, but we don't know. Maybe there's a hole here, or maybe there, whatever, and there's something weak. We have rock, but in this specific point, there's a hollow or space or whatever. And that happens in Europe. In Europe, and every time you dig something, you start finding skeletons and dead people. And you say, what's this? I don't think it's that way in the United States, but you don't know what the soil is. So if you connect all of them, if there's something weak in this part, at least they are all connected, and the whole thing will work as a slab, almost as a slab. Okay, there's something that I don't like. We have to calculate this for sure, but if you see the thickness, or yeah, it's of the beam, it's higher than the footing. Okay, we can either change. It depends on the calculations, but this is ugly. So we can either change the beam or the footing. Let's change the beam. Okay, so let's do this. We are going to edit type. And then we're going to duplicate. Well, first, before doing this, we need to find out the dimensions of the footing. Okay, so the dimensions of the footing, if we edit type, we know that the thickness is 1 foot 6 inches. Okay, so let's make the beam height a 1 foot and 6 inches. So we can select this, we can edit type, and the H it would be 1 foot. I know first we duplicate. Well, you have to duplicate and create another footing. I'm not going to do that because, well, I'm okay, because I want to change all the beams at the same time. We apply. Okay, there you go. That's better. Okay, I told you the size of footings, the thickness of the footings and the beams depends on calculation. That this is feasible. So if we have a footing and the beam connecting is the same height, it's good. Okay, so now we have our first footing system. Make sure that everything is on it's below the first level. And now let's continue. Let's continue with columns. Okay, so when we have footings, we go to structure. This is what we need. So you select here. So we need to place columns, and we're going to place steel columns on these footings. So let's do it. We have beams and columns. So select columns, structural column. And we have this MW shape, and I think this is the only one. Okay. These shapes, this MW shapes column, okay, so this is what steel structures are like. So we have these connections between columns, beams, and they are all these they have different sizes depending on the load. Okay, so we have to change the size of the beam or the size of the column, but all these structural elements are like this. They have this shape. Okay, and this is what if we go to a construction site, we will see a lot of beams like this. Okay, so that we have this I shape, and here we have a lot of tables and schedules for dimensions, but this is the W shape steel structure. So there are elements like this. We have T's, we have channels, C shapes. We have hollow tubes or pipes, rectangular or circular. We have T shapes, L shapes, C shapes, H, W, M shapes. Okay, we have a lot of, but they are all the same. They all have this shape. Why do they have this shape? Because it's the most efficient in terms of material. Okay, so we have to save material because steel it's very heavy and it's very expensive. So, well, mankind has found out that this is the best shape when it comes to structural elements for steel. So that's why we all have these shapes. Again, we have to calculate this 250 times 73. I don't know if you have these or you have others, but we need a steel column. We are not concerned about the size, but we need a steel column here. And by default, I have this one. So what can we do now? So again, we can go one by one and we can place it here, or I'll use the add grid option, and I will select all the grids. I'll click OK or finish. Not gonna do to exit the command. No. Why? Columns, add grids, finish. Okay, there you go. Then we remove column. Okay. And now if we open the 3D view, what is this?
Yeah, I got the same thing.
Yeah, so we have done something wrong. Why? So undo, because when we are doing this, the level is 0. And I don't know, by default, we have an offset. So type 0 here. Okay, even if it, so you have to, it has to be on level 0. So let me insert this one. Why? Well, you see that positive value. Okay. You see that this is from level 0. We have an offset, negative, whatever. That's the issue. And the top level is 0. So let's change this. So let's say top level 12, offset 0. And now it works. Okay. So that's the crazy thing in Revit. Sometimes it makes decisions. I think it realizes that it's more powerful than humans, and sometimes makes weird decisions. Anyway, this is what we have to do. Okay, so make sure that we should be able to change this. It's on level 0. No, it doesn't work. Okay, so let's insert the first one, and now just we can use the array again. So we have 1, 2, 3, 4, 5. So there would be 5 elements. Move from the first to the last, and then we can select the first point and then the last point here. There you go. Okay, now check the 3D, and it worked well. And now we can select all of them. Go back to level 0, copy. Okay, Dylan, I see that you have none of the. Don't worry. Follow the lesson, and then I'll get back to you with all the families. Don't worry. Well, when we are working with this, be careful, because you see that we have thin elements, and if we pick the wrong point, we will make mistakes. So make sure that we are picking always the end point, or the center, or the intersection between these two grids. Okay, so now we have multiple, and we can copy this here and there. We don't want columns here. I'll show you why. And there you go. Okay, so we will be doing something like this. What is this? I told you that we have different modules, and we are going to work like this is like a sports facility, and this is the court. So for the court, we need a long span. This long span is 48, because this is 24, 48. I think 48 is good for a basketball court or something like that. Then we can have the dressing rooms here, or the offices, or whatever, or the toilets, or the restrooms, or and we need small spans, a small span. And here we have even something smaller with 12 feet. Okay, so this is 48, this is 24, and this is 12. Okay, so we have footings, we have columns. If you are having trouble, let me know. If you don't have families, don't worry, or well, don't worry, just attend the lesson, and then try to do it on your own, and I will send you the families. What's next? Okay, so now we have these structural columns that go from level 0 to level 12. So let's work on level 12 now. Okay, we can see the columns here. I don't know, I suppose that you know that clicking here, we have fine details and we see the whole shape of this. If you have coarse, you see that only, okay, so it's better having fine details. Well, now it's time to insert steel beams. Okay, so we can insert, this is the concrete beam, but now we want to insert the W shape. So let's start from this point. And okay, so let's just insert this one and then we will copy, because I want to show you what to do and then we will copy everything. So we can do this and then this. Three. And 4. Okay. What happens? You see that the reference level is 0. Why? If I'm on level 12, I don't know. But you see, if you click here, the reference level, now it's level 12. So I think there's something. Oh, there's one missing here. Okay. So beam, level 12. Okay. So we have 4 beams here. We have to calculate that. Okay, so we have a column, then we have a beam. But without calculating anything, we should understand that the beam for this span should be lighter or should be smaller than the beam for this large span. Okay, so we have a 12 foot span. The beam should be smaller than a 24 foot span. Okay, but keep that in mind. Now I want to show you something different because we have this and 12 by 12 is too large for slab. So we need secondary structural elements. And again, I show you what the masters are doing. We see that we have those large beams with a long span. Then we have another order of beams that are resting on this beam and that beam. And then we have smaller beams. Those are beam systems that have this short span in this direction. Okay, so this is what we have to do with steel and concrete. When we're working with frames, we need a large span. Then we need a huge beam here. Then we have shorter spans, and then we have the shortest span with the smallest beam. So this is something that you have to internalize, even if without calculating anything. Okay, but if you don't calculate anything, but you need to know that the longer the span, the thicker the beam should be. So imagine that this is good for that span. If we have a beam system in this direction, it has to be smaller. What do we have to do? We have to insert, where is it? Insert, family, and now we are going to work with structural framing. Okay, so we see US Imperial, structural framing, but now we are working with steel. We have already inserted concrete beams. Now we are going to do this with steel. And we have a lot of options. This is the C channel I showed you before. The American standard. What is the American standard? Yeah, another. And we have a wide, W wide flange. Welded structure. This is a T. So we have C or channels. We have T's. Where is the T? We have this American standard, and we have the wide flange. I don't know, it should be the same, either the American or the, so to be consistent, because we are working with, or at least in my computer, I don't know, but either this American or this W wide flange, it would be fine. So I'm going to select this one, okay? Open. And now this is a family. So within that family, we have all these types. Okay, so they have the same shape, but with different dimensions. So we can select, well, there are some of them that are obsolete. Okay, so don't select that one. And here we have different dimensions. This is for the, let's see what happens with the, with that structural framing steel, with that American standard, because maybe if you are using an American version of Revit, you have this American standard. Okay, so it's the same. So those are the dimensions, 24 times 121. They are the dimensions of the short and the long dimension of that beam. We can select a few of them. No, but I want to select still this white. Okay. So what is our beam? What is the beam that I have by default here? Is 310 and 38. So it's quite big. Okay. So let's load the family. Still white flange. It was 38 and 300. Okay, so let's select something smaller because we're going to need something small. Yeah, let's say 10 by 100. Let's select like 3 of them. 10, 12, 14, and 16. Okay. It doesn't matter, just select 3, 4 of them, because selecting all of them it would be overwhelming. So because we need a bigger one and a smaller one. So let's click OK. And now if we go to structure and we select beams, we should have different options here. Yeah, so we have this is by default, we have the concrete rectangular. And then here we have 1, 2, 3, 4. Okay. It doesn't matter, it doesn't have to be 10 by 100 or 12 by, just select 110, 112, 114, and 116. Okay, so now we are going to create a beam system. We have beams, we have columns. Now we are going to create a beam system. So if we want to create a beam system, this is very useful because we don't have to create one beam and another and another. We can pick supports. Okay, so here, if you go, you can pick supports. That means that we are going to create that beam system within a square or a rectangle. That's very important. We need 4 elements. So if it's not closed, we can't create a beam system. Okay, so let's pick supports here. 1, 2, 3, 4. 4. Okay, ugh, done something wrong. Cancel. Let's do it again. Beam system. Elevation 0. Well, you see that it's on work plane, it's on level 0. So let's change because we are working on level 12. So you can set work plane, and that would be level 12. Okay, we can change that later, but at least now I found now work plane is level 12, so that will work. And now we can select pick supports, and 1, 2, 3, and 4. And now we can either select fixed distance, 6, or a fixed number. So we have 6 number of lines. Well, let's see what happens. Okay, but let's select fixed number and let's say 6. And we select finish. And there you go. And now you can select one by one. You see that you can select that beam, or if you have some, yeah, or we can select the whole beam system. So if we select the beam system, maybe 6 lines are too much. So let's type 4. Yeah, that looks better. And we can change the beam type. Okay, so by default we have this one, but this is the biggest one. We want to select one of the smallest ones. So let's say this 10. Well, this is smallest, or this is short. Yeah, it doesn't have the same height. Okay, so this is smallest. It's not the best option. Let me see this 12 by, okay, I like this better, 12 by 14 and 16 by 26. Okay, I like this 12 by 14 better, because I think it's clearer that this beam is thinner than this one. Okay, the other one was a little. Anyway. And now we can copy all these. So if we are on level 12, we can copy the beam system.
Would you know why it keeps putting beam supports on level 0 and level 12 for me?
The supports, I mean the columns or the beam system?
The beam system.
Okay, so for the beam system, I'll show you again. If you select beam system, you have the work plane here. You see?
Yep.
So in your file is level 0. Is it?
When you click on the beam system, 1 second. I just had to delete it out because it wasn't working.
Mm-hmm.
So beam system, select. I'm not seeing what you're seeing.
You don't see the level here?
Is that after you created it and you clicked on it?
No. Even when you click here, beam system, without doing anything else, you have here the level you are working with.
Okay, so beam system. Yeah, it's grayed out for me though.
And it's 0 or what?
It is 0, yes.
0. Okay. So before doing anything else, or let me, okay, beam system. Well, sometimes you have to decide whether automatic beam system or sketch beam system. So let's use sketch. So when you use sketch, here you have set work plane. You see?
Okay.
So if you set work plane here, you can change. So if you're on level 12, you can set level 12, and then here
Okay.
it should be level 12. Okay.
All right. So once you switch it to level 12, it should be good.
Yep.
Okay. Thank you.
Okay. So I have done this by selecting this command, pick supports, or I can draw a rectangle between this. So I will draw a rectangle between this point.
It's
And
still
yep.
put it on the first floor for me.
Really? Okay, let me do this, and then I'll be with you. Okay,
Alright.
look at this. I have created this rectangle between these supports, and then I click here, and now I have this. Why have we changed the direction? Okay, we can control that. If we select this, and if we edit boundary, you see that this is the beam direction. So these are parallel to this line. If we change beam direction, so I want all these beams to be on the same at the same direction, then you do this and you change it. And I don't know, by default it's 6, and we are working with 4. Okay. Okay, share the screen, please. Corey.
I should be all set. Sorry, I figured it out.
You figured? Okay, great. So
Thank you.
I'll share my screen again. Okay, but there are different ways to do this. If we have supports, we can pick supports, and we have the beam system. If then we can copy the beam system. But even if we don't have supports, we can create the beam system just by drawing the rectangle. Okay. What's next? Well, those beams are floating, and it's not acceptable. So we have to copy all these. Okay, we have to copy these beams. So let's copy 1, 2, 3, and 4. Okay. Oh, we don't need this one. Okay. So now you have created your first beam steel structure. We have columns, we have beams, and then we have a beam system with thinnest beams between these main beams here. So now let's do the same here with this large span. Okay, so we go to level 12, and let's create the beam. So select this one, and let's make the long one here, and another one there, and the last one here. By the way, I think they are, oh no, they are not level 0, so we're good. Okay, a second thing that you need to know, or you need to learn today about structural systems. If we have a long span and we have a short span, the beam system, the beam system is going in this direction, in the shortest direction. It makes sense. Okay, so if we want to create a beam system here with these two elements, beam system, oh, structure, beam, either a rectangle or peak supports. So 1, 2, 3, 4. We are at level 12. If you are not at level 12, you have to set another work plane. Now, what about the beam direction? The beam direction is this. You see that I think if we look at the top view. Okay, so you see that the beam direction is here. And now we want the other direction, the perpendicular direction. So you select beam direction, this one. We click OK. And there you go. Okay, so if we have a different span between two columns, the beam system has to go in the short span. That is what makes sense. So now we can copy. We can go to, or we can select everything here. 1, 2, 3, and we have to select the system here. And now from level 12, copy 1, 2. Oh, there's an overlap here. Okay. Okay, so what happens now? I have copied this and I think I have two beams here. So if I select one and I delete, yep, there's another one there. And here it happens the same. Okay, be careful with this. Maybe you don't notice, but if you want to calculate things, you are calculating the double. So, okay. So we have footings, columns, a short span with a beam system, another frame with different spans. So the beam system should be in the short direction. Okay, so it looks like a building now. But what do we want now? Those are the dressing rooms or the toilets or the restrooms or other spaces. And here we have the court. Okay, so for the court, we need to make the structure higher because this is 12 feet is good for a plan for a dressing room. But if we want a basketball court, it has to be higher. Okay, so we can select all these columns, sorry. We select the columns and we change the no, we can't do that. Level 0. Right. Oh. Okay. I can't change the level. Yeah, because this is okay. I have created an array of elements. So now I can't work with all of them because they are a group of elements. So if I ungroup, yeah, now I can change, you see, but I think I have to ungroup all of them. Okay, so don't create arrays, because if you do that, then you have to ungroup all the columns. And now I think if we select all of them, yep, we change the top level. So let's make the top level 36. And same thing here. If we select all of them, we have to ungroup. And then we can change the level. To level 36. Okay, so now it has the dimension of a basketball court. We have 48 feet and we have 36 feet high. This is, yeah, so it looks like a sport facility. Okay, when we are working with these long spans, more than 24 feet, beams are not enough, and we need another structural element. We need trusses. Okay, so this is a truss. A truss is a structural element, a horizontal structural element that is made of different bars, horizontal and vertical and diagonal bars. Okay, welded together or bolted together, and then we have a structural element. Why do we have this? Well, I'm not going to explain statics. Some of you have taken statics, and I'm sure that Mike has explained this to you. But well, it works better, and especially we save material, okay, because we don't have a solid element. We increase the distance by the top chord and the bottom chord, and by increasing that distance, we have more resistant with less material. So that's the idea of having trusses. And if we are working with a structural template, we can insert trusses. No truss family is there. Maybe you have some families. If you don't, insert, load family, and now you have to go to structural trusses. And here we have a lot of them. Trusses are named after people. So this is Mr. Fink, Mr. Ho, Mr. Pratt, Mr. Warren, and that's it. Well, maybe they designed this and they named the truss after the designer. Okay. So let's use a Pratt one, because the Pratt is like this. So we don't have a weird shape or a triangular shape. I want something flat to make things easier. Okay, so let's use the Pratt flat truss. Open. And where are we? Now we have to place the truss on that level. Okay, so we are on level 36, and we have to place the truss here from this C grid to the E1 without anything on the D. Okay, so we don't want a vertical element here or a column here, because this is a basketball court and we need an open space here. So we're going to, we have to go to view, because I don't have level 36 here. Plan view and level 36. Okay. So this is the truss. By the way, if you are doing this, make sure that all the drawing is within the view range of these elements. Okay, so make sure that everything that we are doing is within this element. And now we need traces. So we need a trace between number C and number E. So we go to structure, trace. We have this prat. And let's work with the first one. This is the first. And here. There you go. Well, it's ugly, but we can edit this. So if we click this here, we can edit the family. Cancel. We can edit the family. Okay, so here we can change the dimension. So let's make it something crazy. Okay, it doesn't make any sense, but we can edit the family, and we can edit the type. So here we have the top chord, the bottom chord, and then we have the vertical and the diagonal webs. And we can set framing type here. So by clicking here, I can change the diagonals and the, yep, there you go. Well, I think I have created, if we edit type, yeah, I have selected the concrete rectangular, so it has to be this one. Okay, so now they are different. Those are thinner than the original. It's not, I'm not happy with this. Let me insert another structural framing. Still, let me try with the American standard, and let's select the smallest one. And then I'll edit type, and I'll select the American standard. Okay. This is, we have the top and the bottom chords. Those are the biggest elements. And then the vertical and the diagonal webs are thinner. Okay, so that looks better. So when we have decided this, then we can go to level, I think there's a problem with the view range. View range, make it limited. Okay, there you go. This is the trace, and then we copy. There you go. Okay, so this is it. Is it okay if we use a different beam? Yes, it's okay. Erin, do you want to share? I mean, I'm going to.
That was like 30 minutes ago. I figured it out. We're good.
Ah, so you, okay, sorry.
Sorry.
No problem.